There's two different types of right triangles. One is the 45, 45, 90, and the other one is the 360, 90. This one you can see that both x sides are congruent to each other, and this side is going to be x squared too.
So here we have the 30, 60, and 90 degree triangle. So the side opposite to 30 degrees is always x, and then the side opposite to 60 degrees is always x root 3, and then the side opposite to 90 degrees is always 2x.
The first triangle that we're going to look at for an example is the 45, 45, 90. So in this example, we're given the hypotenuse, which is 6, and we need to find what x is. We set this up by putting 6 over root 2. We get x is 6 root 2 over 2. And to simplify that, we'll get x equals 3 root 2. The next example we'll be doing is for the 30, 60, 90 triangle. We are given 8 root 3. This being said, x would equals 8 because 8 and x. We would multiply 2 times 8 to get 16. So our values will be 8 and 16.
Now we're going to be talking about SOHCAHTOA. This basically represents sine, cosine, and tangent, and then these represent the formulas for that. So this is our triangle we're going to be using for an example.
So sine is the first part of SOHCAHTOA, and it's represented as opposite over hypotenuse. And then as you can see on the triangle, relative to x, this is the opposite and this is the hypotenuse.
The second part of SOHCAHTOA is cosine. So cosine is always adjacent over hypotenuse, a over h.
Okay, so now we're going to be talking about tangent, which is again relative to x. So it's going to be opposite over adjacent. This is opposite over adjacent.
So this is our example where we are given 9, 13, and 55.3 degrees, which will be our theta value. And so this is a tangent equation because it is always opposite over adjacent. Our exact value will be tangent beta equals 13 over 9.
So this is the trig function unit circle, and it's all the triangles in each of the quadrants. So this would be the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant.
So now I'm going to be explaining about the 6 trig functions. The first one we're going to be talking about is cosecant, which is basically the opposite of sine. You're going to be doing 1 over sine. So originally it was opposite over hypotenuse, but you're going to be flipping it to hypotenuse over opposite. The next one we're going to be talking about is secant, which is basically 1 over cosine x. Originally it was adjacent over hypotenuse, but you're going to be switching it to hypotenuse over adjacent. And the last one is cotangent, which is again 1 over tangent. Originally it was opposite over adjacent, but you're going to be switching again, and it's going to be adjacent over opposite.
This is an example for the basic 6 trigonomic functions. So the example we're given is tangent of m is 19 over 17, and this is the triangle, so we are given 22, 19, 17, and we're looking for the values of m. First one is sine, cosine, and tangent. So sine opposite over hypotenuse would be 19 over 17. Cosine of m would be adjacent over hypotenuse, and that is 17 over 22. And tangent of m is opposite over adjacent, so that would be 19 over 17. Cosecant of m, which is hypotenuse over opposite, that is 22 over 19. Next one is secant of m, which is hypotenuse over adjacent, and that is 22 over 17. And the last one is cotangent of m, and that is adjacent over opposite, and that would be 17 over 19.
So this is an example of the triangle on the unit circle. So the problem is asking, given cosine theta equals 4 over 7, quadrant 4, find all 6 trig functions. So as was explained previously, these are the 4 quadrants, and then this would be the 4th quadrant, which it says in the question. And then you have to find all the 6 trig functions. So sine of theta, you would solve for that, and then you get root 33 over 7. And then it's given cosine of theta, so you know it's 4 over 7. And then you find tan of theta, and you get root 33 over 4. And then for cosecant, you get 7 root 33 over 33. And then for secant, you get 7 over 4, and cotangent 4 root 33 over 33.
So last thing we're going to be talking about are multiples of a triangle. So any multiple of 3, 4, and 5 is going to get you the same triangle side lengths. For example, this triangle obviously has 3, 4, 5, and if you multiply each side by 2, it's 6, 8, 10, which is the exact same thing as this triangle.